Good afternoon. My name is Jeremiah Dutton, and I'm here today. Bjorn invited me to give a short talk about the trends in natural fibers and the experiences that we've had building the Volkswagen rallycross car for KMS. For those of you that aren't so well versed in the history of motocross, like myself, actually, I'm a rugby union fan at heart, so I didn't know too much about what rallycross is when we started. Really quickly and basically, you take a factory car, you strip it of all of the essential parts that it usually needs to be roadworthy. You stick an engine in it, which makes it go from 0 to 100 in 2.1 seconds. So that's about faster acceleration than an F1 car. Then you take off all of the body panels, the internal panels, everything that you can to do to save weight and put it right underneath the driver so that he can take those hairpin turns and make sure that he jumps just when he needs to. And for us, this was a wonderful project, because we're a small startup that's working with natural fibers, and we really had been doing small scale at that time. And this was a trial by fire. So how to produce not just a bumper, but all of the carrosse. So all of the body panels plus the internal instrument panels. And to make sure it was light enough and strong enough. It was a very fun project, taking the ideas out of the lab and onto the track. And of course, after one heat, it's a little beat up, because this isn't, oh, am I standing in the way? I'll move. This isn't like other motocross, or like other motorsports. This is actually a full contact sport. So it's intended that you take these supercars that you spend $1 million on and then put them in an arena with 5 other cars, not only taking jumps on pavement and on dirt, but it's basically then a crash-up derby. And as long as you're out front early, maybe your car stays in one piece. So that first shot is really important. Lots of fun, and we met Tommy Kristoffersson, a legend of Swedish motorsport, last year at the beginning of 2014. And like all eager young startups, when he asked us, guys, what do you think? Could you help out? Could you make some composite parts? What do you think? We of course said yes, absolutely, we can do that, not a problem. There was one small catch though, and that was that we only had 10 weeks until the first race at Rings Knutstorp. So luckily, we teamed up with wonderful partners, Cliff, Mats and David at Cliff Production, and we realized this project. We actually got the car onto the track in time and made sure that they had all the parts so that they could make the race, and all their races actually. So it was a really, really fun project to do, to baptize ourselves by fire and to really test our composite material. To give you a little bit of flavor about what it entailed to build this car, which required over 100 molds, 100 plugs to be flashed, 100 molds, and roughly about 50 different parts to be made. We made a short video that we'd like to show you. Does the sound okay? So yeah, I'm a rugby fan, but I still would like to drive that car, I think, before I die. It's not going to happen, but I'd like to. A little bit first also about what we do at Trifilon. Maybe a few of you saw that there was a word patent that got thrown up there. In 2007, a couple of innovators out of Linköping University were looking around to try to understand how do we create a recyclable carbon fiber. They were looking to try to see what they could do. And unfortunately, as most of you know, carbon fiber doesn't really break down that well, not so organic. So what they finally landed upon was when you have a multi-layer composite component, if you simply take out a few parts, a few of the layers, and replace it with a natural fiber, there's actually a lot of improvements. If you do it in the right way, it can be realized. And so that's what we do at Trifilon. It seems like a really, really, really simple idea. And it is, but it's not obvious. And when we go and we tell, for instance, and we speak to boat builders or kayak manufacturers or anyone that's grown up in the school of glass fiber and carbon fiber, it doesn't make sense to them that replacing something that has a lower tensile strength, a worse flexural strength also, that you'd see improvements, but you do. And that's simply because what you're doing is you're actually creating a micro sandwich. And in that micro sandwich, you're getting a better flexural strength. Unfortunately, the tensile strength isn't as good, but you're also having improvements in vibration absorption, dampening, crack propagation, a lot of really, really positive mechanical improvements. And one of the big points that I'll show later also, natural fiber. It's lighter than carbon. It has a lower density. Many people don't know this. So that when you build a pure composite part and you include natural fiber, your end product is actually lighter. So, again, not according to the conventional wisdom, but sometimes you need to look outside the obvious to find innovation. When Bjorn asked me to come and speak today, I didn't want to just speak about Trifilon and what we're doing. I thought it would be much more interesting to talk about what I see happening in the wider world in regards to natural composites. A couple of months ago, we were down at JEC, which is the large composite fair in Paris, and you see year on year on year, more and more and more natural fibers coming out onto the market. And so I thought that might be an interesting discussion point. Where are we going to be in 10 years? And I looked at the data a little bit, and I thought about it a little bit more. And I think in 10 years, the composite industry is going to look completely different. Completely different. The status quo will have changed. When you call up Dan at Svenska Tanso to order your carbon fiber, which you do nowadays, or your glass fiber, instead you'll be calling him to say, please send me over a 200 gram of hemp or flax or sisal or kanaf. And there's a few good reasons why. And I'm reminded actually of the horse when I think about this. So the turn of the 19th century was when the horse population peaked worldwide. Lots of horses out plowing the land. We were starting to see greater urbanization. But there was a paradigm shift coming, and no one really saw it. There was these things that were sputtering along the streets sometimes, called automobiles. But the horse had been around for 100, 200, 300, I don't know how long it had been domesticated, probably 1,000 years. And it was unlikely that it would be replaced in such a short time. And yet it was. It was a very, very shift, actually. It was a paradigm shift that happened within probably 20 to 30 years. And I think that's what we're going to see also in the composite industry. And from a wider perspective, you see these megatrends floated around by The Economist or the McKinsey Group. Accelerating urbanization, climate change, scarcity in resources, demographic shifting, the global economic power centers moving away from the US or North America, more and more towards Africa, where you're going to see an explosion in population, and also technological breakthroughs accelerating. During the last 100 years, technology has kept a pace. But in the next generation, in our generation, I'm sure that we will see new technologies that we can't even fathom. And it is these innovations, for instance, autonomous driving, the need to do more with less, the fact that we can't continue to produce energy the way that we are. We need to look at renewable sources, wind power, for instance. And we can't also continue to maybe make synthetic materials. Maybe we need to look at biosources. If we look at today, over the last 60, 70 years, now that we've had synthetic fibers out in the market, fully commercialized, how far have they come? My friends at Lucentel broke it up like this: transport, marine, aerospace, wind energy. And as of 2014, not so much market penetration, actually. Surprisingly little. Surprisingly. Transportation, 3%. Wind energy, yeah, 20%. That's all the blades, I get that. Aerospace, 25%. Okay. I get that. But I would have thought it was more. And what does that mean? How big are these markets? They're quite substantial, actually. So why haven't synthetic fibers, glass, carbon made it in? What's holding them back? I'm reminded of my favorite American president. I'm Canadian, so no offense, I'm not American, Canadian. But I do have one favorite president, and that's President Clinton. And his line in 1992, "It's the economy, stupid," right? Everyone was talking about NAFTA and what have you. No, it's the economy, right? So what has happened with synthetic fibers, especially carbon fiber, in the last 50, 60 years? Why hasn't it been used more? Well, think about it. Where has it been used? It's been used in expensive hockey sticks, maybe some skis, so luxury items. Now we've seen it going more and more into aerospace. But again, that's not for the mass production of automobiles, for instance. It's not on the same cost basis. And if we look, why hasn't it replaced steel, for instance? And this $2, that's really low-grade carbon. That's going to be tough to find and tough to use. SGL and BMW recently, or rather BMW recently bought SGL, which is Europe's largest carbon fiber manufacturer. And they've set a goal of reducing carbon fiber, the price of it, by 90%. They've reached about 50% already, which is impressive. But they're starting from such a high point that it's still relatively expensive when you compare it to steel. Typically, the carbon component costs usually 5 times what a steel component would cost. So unless you can make sure that you're having a significant weight savings, or that your customer is willing to pay for it, for the aesthetic reasons often, then it doesn't make sense. And I thought this was a really interesting quote that came out of this year's Composite Worlds Conference in Miami. And it wasn't by anyone small. It was by the VP of Aircraft Materials for Boeing. And he said, "The extensive use of composites in the 747 does not guarantee similar use in future aircraft." What? They invested so much money. It's going to be a tougher sell in the future to go to an all-composite airplane. Wow, I was not expecting that when I first read that quote. And of course, there's a number of things that are baked into that besides the raw material price. It's of course your huge costs in tooling and new manufacturing process. And of course, the immaturity in the simulations. If you look at the standards and the simulations and the software that is available currently for composites, it's 10, 15 years behind that of steel and aluminum. So it's really hard for composites to compete, not just on the material side, but then also how to bring it in and manufacture it and ramp it up. But of course, if you're at least starting from a much cheaper input cost on the material side, maybe it's easier to get it into your production. So just to get some production figures, that's always nice to see. Where are we sitting at? Well, carbon fiber, 50,000 tons? That's a lot of carbon fiber, actually. Yeah, I guess. Glass fiber, that's substantially more. We're talking millions. That's a lot more. Then I asked a couple of my friends actually that work in the forestry industry, Anna, to send me some figures, which she obliged. And it was interesting to see how much, for instance, just pulp and paper that one country, a little country called Sweden, produces. These are fibers that maybe not all of them could be used for composites, for some of them. So the pulp and paper production in 2012, substantially more. We're looking at almost 10 million tons just coming out of Sweden. This isn't raw timber. This is just pulp and paper. So when you add up all of that, you're sitting at a much, much larger number. I was trying to put this graphically so I could show it, because it was hard for me to, I was putting it on a bar chart, and the carbon was so small, I couldn't get it on there. It wasn't even worth viewing. So I thought instead, okay, there's one dump truck. That's 50,000. That's what we produce today in carbon. Glass fiber, yeah, it's about 10 of those. You know, it's quite a bit. But then I wanted to put that in relation to pulp and paper in Sweden, just so we get a visual of how much fiber is actually out there that could be used in natural fiber composites. So it's orders of magnitude larger. And this is short fiber, though, I'm still speaking about. So not the long fiber that I work with today, which is mainly hemp. There's also flax. There's also a number of other bio-wastes that exist that could be also used. Even though they haven't passed the law to allow the growth of industrial hemp in the US, you're actually allowed to grow medicinal marijuana, but industrial hemp you're not allowed to grow. This came out just in February of this year about the global production from the Congressional Research. So roughly 90 million tons of hemp fiber, not seed. This isn't hemp that is grown for seed crop, for food. This is only hemp that is grown for fiber usage, which could be used then for industrial purposes. So 90 million tons globally per year. So substantially more. So now, okay, there's a lot of capacity in natural fibers, I got it. What else is there? Well, I mentioned earlier that it's light. Almost all the long fibers have a lower density, 1.3 roughly, 1.3, 1.4, than carbon. Carbon sits around 1.8, glass around 2.4 to 2.8. So you've got a fiber, you have an excessive amount of fiber that is very, very, very low in weight, just sitting there. And of course, we've been using natural fibers for hundreds of years already in ropes and in other construction means. They're not as strong as synthetic fibers. They're around 800 to 1200 for hemp and flax, megapascals. Glass is sitting around 2400, carbon anywhere above that. But when you start speaking about specific strength, so you take in, well, how much does it actually weigh? And then you take the strength also. And they're actually hemp and these long fibers, they can compete with glass fiber quite well. So then maybe it's only a question of how you design your part. What's your geometry? How thick is it? And even maybe if it's just a little bit thicker, maybe it's still lighter. And maybe it's orders of magnitude lower on the cost side. And then the next question is, well, what if you do start doing hybrids, like what we've done? What if you start really making things complicated? You add a little short fiber, very inexpensive, huge amounts out there with long fiber, and then just enough synthetic fibers. What sort of composites could you create? What sort of price levels could you achieve? What sort of weight could you save? I have a couple of friends working in natural fibers. You get these kind of friends, I guess, up at Inventia at KTH that are looking at nanocellulose. Really, really, really interesting. So this is the building blocks of all plant material, and it's super, super strong. It's very homogeneous. So that's always one of the big downfalls of natural fibers. Why hasn't it been taken up yet into the composite industry? Is because the challenge back is, well, show me the consistency. Because when I go and buy carbon or glass, I buy a bag of it today, and it's the same as it's going to be a bag of it tomorrow. Natural fibers, it's a natural crop, so it's going to vary. Unless we learn from the paper industry, who can deliver the same thing year after year after year after year. And with nanocellulose, there are other challenges there. It, for instance, loves water. It is hydrophilic. And it absorbs water too much. So these are some of the challenges that need to be overcome before we can start using it. And also the fact that it's only at a lab scale now. Taking also a step back and looking at, yeah, there's a lot of interest in this. Is there also interest coming from the academic world? I found this report, I believe it came out of Brazil, and it was, 2014 wasn't complete yet, but what you see here is a really big uptick just after 2010 in the amount of research that was starting to happen on natural fibers. Why was that? What was happening? Besides maybe, if I think back, yeah, there was discussions about megatrends and resources becoming scarce. There was also one other thing. I remember this, and this was the newspaper extinction. So you have a whole bunch of excess capacity, and then you have producers that are going to see one of their cash cows, one of their revenue streams disappear in the near term. America, Canada, where I'm from, what is it? 2017. It's a couple years away. So it's unbelievable, or 2020, sorry. It's unbelievable. These global companies are going to need to find new applications where they can use their millions and millions and millions of tonnage of fiber. And so I hope that in 10 years I'm not going to be that horse that didn't see it coming, that didn't see the automobile coming and just, no. I want to be part of this challenge to really map out how we're going to use natural fibers, understand what are their material characteristics, how do we present them in a way so that industry can use them, understand their needs, so that then we can create a custom natural fiber reinforcement that fits into their product. Maybe initially just as a simple drop-in, but then later on maybe we can do a full integration and redesign the product. And of course, it's not going to be easy. When we started, we really weren't experts by any means. But of course, you know, building a car, doing a lot of different samples and tests, you find your way out of that paper bag eventually. And I hope we can change that to being, it's not the economy, but it's natural fiber, stupid. And of course, that's going to be happening by, again, what we're doing, continually pushing the boundaries, understanding what is possible with natural fibers, what's possible with mixtures and hybrids, so that we can find a way forward. Thank you very much.